guys, my name is Julien Chaumond and I'm the CTO of Hugging Face. Today I'm going to talk to you about the Hugging Face Model Hub. So first, Hugging Face is a NLP and machine learning company. We are based in New York and in Paris, France. We are building very popular open source libraries, and this is all with the support of the community. So one of the library is the pretty famous now Transformers library. We are very lucky to have close to 30,000 GitHub stars. Another one is tokenizers, so basically fast tokenization in Rust to accelerate your NLP workflows. And finally, the NLP library recently released is basically a dataset and metrics library. If we go back to Transformers, we have more than 1,000 companies using models from this repo in production. And even more, we estimate that we have more than 10,000 machine learning engineers and scientists who are training models using the repo and then sharing them with each other and with the community. To support this sharing of model, we built the Hugging Face Model Hub, which is the subject of this talk, and so I'm gonna demo it right now. So this is huggingface.co. It's the homepage of the Model Hub. Let's click on models. So if you click on models, you're going to see a big list of models. We have close to 2,000 models right now that were shared by the community. And so you're going to be able to filter them using a few different tags. So obviously, I'm going to zoom it a little bit. You're going to be able to filter by framework, by machine learning framework. So obviously PyTorch, TensorFlow, and a few different ones that we are going to explore a little bit more in the future. Type of model. LM head means language modeling head. I'm going to talk about this a little bit more later. And obviously text classification, token classification. Those are basically types of model that you're going to be able to filter on. And obviously, language is at the heart of what we do. You can filter for specific language for the models that are trained on specific data sets. For instance, if you look for models for French, German, Dutch, Italian, you're going to be able to filter them. Let's dive in and look at a few model pages. I'm going to start with Roberta. So Roberta is a carefully optimized version of BERT. BERT by Google is a really important model. Obviously, Roberta kind of built on top of BERT with a few different pre-training tweaks. So on this model page, what you're going to be able to see is like first stats about the downloads of the model in the last month. You're going to be able to see a snippet of code here. The snippet of code shows you how to start using the model in the Transformers library. And we are going to add very soon another sample code that will let you use the model inside our pipeline feature. Third, you're going to be able to see a model card. So a model card is supposed to be a textual description of the model, of its training and its limitations. Now the model card for Roberta here is very empty. Most models have way more detailed model cards. So please, if you see a model card that's not very detailed or even doesn't exist, please contribute, open a pull request on GitHub, improve the existing ones. It's an area where we really want to improve things in the coming weeks and months, so feel free to contribute. And finally, this particular model has a link to Expert. So I'm going to click on it and explain a little bit what Expert is. So Expert is a visualization and introspection tool that was developed by IBM Research and Harvard. I'm not going to go into too much detail about Expert, but basically it's a visualization interface that lets you have a detailed view of what actually happens inside the model. I'm not going to say more here, but please check it out and play with it. And I'm going to go back to this page. So a new feature we are starting to roll out is directly on the model pages to expose an inference API. So basically be able to play with the models directly on the model page. So this is something that's very exciting to us. Let me show you a first sneak peek, even though it's not like the final version that we are going to ship. So here I changed a page, I'm in a new interface. The model is still the Roberta base model, and it's still a masked language model. What's a masked language model? So at the heart of all those models is language modeling. Language modeling is the prediction of the probability of sequences of words in a sentence. One of the most popular methods for language modeling is called masked language modeling. So you basically take sentences, mask random tokens or words, and you train the model to predict them back. So this is what's going to happen here with Roberta. I'm going to input, for instance, my name is Mask, and I am an engineer who lives in New York City. I'm going to compute. And so what the model is predicting is it's filling the mask token. So we can see that here the most likely token is Alex. So my name is Alex and I'm an engineer. The second one is Daniel. The third one is Andrew, David, Chris. So basically you can, on this very fundamental task of language modeling, which is masked language modeling, you can see what pretty much every model on the Model Hub is predicting. I'm gonna go back now to the model page and talk a little bit about other tasks than masked language modeling. So another type of language modeling is called causal language modeling, and it's usually used for a generative model. Now, the most famous generative model is GPT-2 from OpenAI. I'm sure you played with this model before. Let's find its model page. GPT-2. You can see it's one of our most downloaded models, by the way. And again, I'm gonna show you the inference API. So again, it's gonna be integrated into the model page at some point. But here is the sneak preview. So causal language modeling lets you feel not masks, but the actual following of a sentence. So I'm gonna check out like a very simple example. So my name is Julien and I am and launch generation. And so in that case, the generated text was, my name is Julien and I'm a French Canadian and I am a student at the university. So please note that the generation is greedy, so it's a greedy sampling. So you're gonna get, in that case, you're gonna get the same generation every time. And by the way, if you want to play more with a generative model, we also have a text generation interface, which is called Write with Transformers. And it's pretty cool. It lets you generate text with a much more advanced control over the sampling methods. So let's go back to the Model Hub now. On top of those pure language modeling tasks, like masked language modeling or causal language modeling, it's very easy to take a model and to fine-tune it to a classification task. Actually, that's what more and more people are doing using the library. So the way you usually do it is you add a final layer to the model. At the top of all the language modeling layers, you add a final classification layer, and then you pick a dataset, classification dataset, and you fine-tune your model on it. Let's see an example. I know that, for instance, a dataset called SST2 it's a sentiment analysis dataset, and I'm gonna check out, for instance, Distilbert fine-tune on SST2. So sentiment analysis obviously is a task of predicting whether a sentence is positive or negative. I'm gonna pick Distilbert Bayes model. What's Distilbert? So basically distillation in the context of machine learning is a type of compression. And so the Distilbert models that we fine-tune or train are easier to deploy into production because they're faster and smaller. So obviously here for sentiment analysis, if I want to use this model in a large scale application, I'm going to try to use the Distilbert version. So again, let's try the demo. Let's try, for instance, a positive sentence. I love pizza. Okay, so here it's like very, very importantly labeled as positive, which you would expect. The previous generation of models sometimes struggled with kind of like ambiguous sentences. So, for instance, I do not hate pizza. The previous generation of model would maybe label that as negative because they were relying on bag of words approaches often, and the word hate is usually a pretty strong indicator of a negative sentence. But here, it's still classified as a positive sample. So it's kind of like showcasing the way that those models, those state-of-the-art models, more and more are able to detect understanding of languages that was kind of hard to achieve before. So that's text classification demo on sentiment analysis. Another pretty funny example of text classification is Roberta fine-tune on MNLI. So MNLI is another data set. It stands for multi natural language inference. So language inference is basically the task of taking a pair of sentences and deciding if the two sentences are in contradiction or if they are in entailment. Like for instance, I'm gonna try I like you and I love you. So this is actually detected as a neutral case. But let me try to find a better example of like so the more obvious example is I like you, I don't like you. So obviously the pair of sentences are in contradiction, and it's gonna reflect here with a very, very high score for the contradiction label. And so on. So I really invite you to play with this demo and to give us your feedback. All right, let's go back to the model hub. I'm gonna show now token classification. So text classification is basically predicting a label for the whole sentence. And token classification is gonna predict labels for each token, which is to say basically each word in the sentence. So we have this member of the Hugging Face open source community who's called Severin Zimmler. He actually fine-tuned a model on the language German and on a corpus of literary type documents. So his model card is really interesting and detailed, so I invite you to read it. And again, we are gonna try the demo. So again, this is a token classification demo, and it's in German, so I'm gonna try, even though my German is a bit rusty, I'm gonna try to write a sentence in German. Ich heiße Severin und ich lebe in Berlin. All right. I hope my pronunciation is not too bad. All right, so here the model detected that Severin, the word Severin, with a very high probability is a person. So basically B-per is a tag for a token of type person. If you're used to demos of named entity extraction, so basically this type of token classification is called named entity extraction, or NER. It's going to extract tokens that represent specific classes of entities. You may be surprised that Berlin was not detected, but actually if you take a look back at the model page, the author of the model specifies that he only fine-tuned the model on entities of type person and not location, for instance. So basically, that really depends on like the data set that you use, the labels that you have. And in that case, it's a model that's really good at detecting names of characters in German literary documents. So if that's the use case that you want to solve in your application, you're in luck. It's a very good model that this author shared on our model hub. All right, one more example. Let's take a look at question answering now. So question answering, basically, question answering the task is given a question and a paragraph of context, the model needs to predict the answer to the question inside the context. So a very popular data set for question answering is called Squad. I'm going to search. And again, I'm going to pick the distilled version of BERT, distilled BERT, fine-tune on Squad. Now is a good time to demonstrate a new feature that we have, where basically models that were fine-tuned on specific data set can link to the given data set. So for instance, here, Squad, you can see that you have like a blue tag here. If you click on it, you're gonna get to a dataset page. And this is powered by the NLP library, the new NLP library that I was referring to. And what's really cool is that on each dataset page, you have a button here that says Browse NLP Viewer. And if you click on it, you're gonna get to a viewer that was built by Sasha Rush. And it's really cool. You can actually, without having to download the dataset, you can actually take a look at what's inside it. So for instance, I was mentioning that question answering takes a context, which is a paragraph, and a question, and it's going to predict the answer to the question inside the context. So basically here, Saint Bernadette. Let's try the demo once more. So that's a question answering demo. So I'm gonna paste. All right, it would be too easy to take a sample from the actual training data set. So I'm gonna take a look for another one. Let me see. Model is in English, obviously. I'm gonna paste like the first paragraph of Wikipedia on the Eiffel Tower, and then I'm gonna ask who built the Eiffel Tower. So you can see that sometimes the model is not currently loaded, so the inference API is actually gonna load it on demand, on the fly, and so I'm gonna be able to, all right, now it's loaded. And it predicted that the answer is Gustave Eiffel. That was pretty easy, that the Eiffel Tower was built by Gustave Eiffel. I'm going to ask a slightly more complex question. When was it built? And the answer is between 1887 and 1889. All right, that's awesome. So I talked about all those different models. I talked a little bit about the NLP datasets library. One final example, which I really like, is the example of translation. So I really want to do a shout out to the NLP research group at the University of Helsinki NLP. So those guys basically used our model hub to share more than 1,000 models with the community, and all those models are translation models trained on pairs of source language to target language. I'm gonna try, for instance, let's try EN to FR. So basically, going back to the demo, if I input sentence. So for instance, my name is Julien and I am an engineer. Je m'appelle Julien et je suis ingénieur. That's good. That's actually a good translation. Now I'm gonna try a different language. So German, I already kind of like talked about it. Mein Name ist Julian und ich bin Ingenieur. All right, awesome. And we could also try more low resource languages. So what's really, really cool about what the University of Helsinki did on our model hub is that among those 1,000 models, you can find like low resource languages, languages where like most of the time they don't have a good support in machine learning libraries or NLP libraries. So it's a good testament to the fact that we really want to democratize NLP. And democratizing NLP is not just for English, obviously, but for all the languages, everyone, and even like including like low resource languages. All right, so that's about the end of my presentation, and I will be happy to answer any question that you would have in the Zoom.